Hi everyone and welcome to my workshop. What I have here with me is the Acmer S1 laser engraver that we're gonna test and see what projects we can do with it. In many of my previous videos I was complaining that I didn't have the means to create enclosures and different parts for some of my projects, so Acmer reached out and asked if they could send the S1 mini laser to test out, and I agreed. So here we are. We're gonna open the box, see what's inside, and we try to do a project with it. We try to engrave on different materials, and also we will try to see if we can build a PCB with it. Now this is definitely one of the smallest lasers that you can get, but it should be good enough to enter you within the hobby. So you could start with laser engraving things or just adding a personal touch to some of your products. It's about 25 by 25 centimeters in size, and the working area is 130 by 130 millimeters. So let's unpack it, set it up, and see what we can do. Inside the box, everything is nice and neatly packed. We have the power adapter and the USB lead. We have what seems to be a material sample and some Allen wrenches. That's part of the machine there. This is the actual laser module and some protective glasses, and this is the actual machine. Let's set it up. So the actual laser module of this machine is 3500 milliwatts or 3.5 watts, and this can come in 2.5 watts and 6 watts as well. And the only assembly that you need to do is to mount the laser on the holder that we have, and we need to tighten this screw here to have it set. Additionally, just a single cable needs to be plugged in and we should be ready to go. Now, before we plug it in, let's look around and see what we got. We have the power connector here and a USB Type-C for communication and a single on-off button that we can trigger. It has nice and sturdy pre-assembled aluminum frame. On the axis you actually have marks for the measurement, so we can probably align the workpieces better. We'll see. Inside the box we also got a full user manual with all of the information that you're gonna need to start engraving, as well as a quick reference to the online manual and related software, and a piece of cardboard stock that we can try to engrave on, two metal aluminum cards that we can also engrave, and the piece of wood that we had from before. Now, before using any laser, an important step is to focus the lens on the material that we're gonna work, and for that we have this piece of acrylic. This is 2 millimeters wide, and the way we do it, we add it on the material that we want to engrave, loosen up the screw, lower the laser on top of that, and tighten it back again. Then we can remove, and now the laser is gonna move 2 millimeters above the material when it's engraving, and it's gonna have the right focal point on the material, which should be relatively precise because the point is actually 0.04 millimeters, so we should be able to get some really precise engravings from this. Now, for the software, the machine has a Gerbil controller inside, and it can work with Laser Gerbil, which is free software, and with Lightburn, which also has a paid version, but it has a 1-month free trial that you can try and see if it's worth the purchase for you. Now, on the machine, both the power and the communication cable come from the front, so let's connect it. We have a light, and let's connect the communication cable. In theory, that should show us here on the device. Okay, that's power on. We heard the beep. We need to figure out which is the right COM port that we're gonna use. So it's COM 10, and that was pre-selected. Let's connect to the machine. We should be live, and let's home it. Okay, that seems correct. Now let's try and do some engraving. Now I have this other material that I'm gonna try and play with. It's I think birch plywood that's about 4 millimeters thick. We should be able to cut it here. You see, this is also cut on a different laser cutter, but I'm gonna try to first engrave my logo on it. Okay, so I have the material in place. We need to set the focus with the right height. So we have our focusing piece. We need to add it on top of the material, fix the laser there, and we can then remove that piece and we can align our material to the best that we can. Now let's move to the computer. Here I have my logo. I think I'm gonna use it as an image. So horizontal, and I'm gonna set about 10 lines per millimeter. Okay. And so the laser can go up to 10,000 millimeters per minute, but I don't think that we have enough power. We need dynamic power with, this is 100%. Let's go about 80%. Actually, that needs to be 800. So 0 to 800. We want to size this to be about 50 millimeters by 30 millimeters because that's the size of the image. Let's create it. Just for a good measure, let's home it again. Let's move it to the center. That looks about right. Let's move it to the home. And an option that we have here is called frame, that we can frame the design and see how big it's gonna be. That is especially crucial if you want to have something that is like if you are engraving on the provided metal cards, then you need to be sure that you are at the right size. So let's do that. Okay, that turns on the laser so we can go and see how far it's gonna go. Okay, that looks about right, and let's run it. Okay, that's now done. It is really nicely and very deeply engraved. I could have gone a lot faster or used a lot less power to get a nicer engraving, but this is super nice, really deep black, and really this is like almost halfway maybe to the material. It's definitely beyond the first layer, so it burned this whole first layer of the material. Now, one thing that we can do to be better familiarized with the power that we should use on the material, we can use something like the material test, which comes from Lightburn, and I have it set here where we're gonna have multiple squares using different speed and different power so we can know what the machine will do. We'll go to the maximum of 10,000 millimeters a minute from 500, and we're gonna be using power from 10 up to 100%. So let's trigger that and see how it goes. Okay, so let's see what we got. We have 500 by 100 power, and anything, I mean, just about 30% power at 500 millimeters a minute should be really nice for engraving. This whole diagonal line here, this is too faint. You could see the text here, which is super precise because this is quite small. Each of these squares is 5 millimeters by 5 millimeters, and we can test the accuracy of that. Okay, let's see with the calipers. And that's about perfect, I would say. Now, before we start with the PCB, I want to do one more test. This is one of the test pieces that I have 3D printed for my palette level sensor. That video you can check up there. I want to try and see if I can engrave on a 3D printed part and how that's gonna look like. Now, one of the challenges with such a small part is aligning it properly. I think I have it generally in the center, and I made sure to focus it correctly. So this is the framing operation, so it looks about right. Let's start it and see what happens. That is definitely usable. That's not deep. We had about, I think, 2200 millimeters a minute at 80% power, and it definitely added the engraving to the 3D printed part. Now for the PCB, I have a piece like this. This is the fiber board on one side and the copper on the other. As it is, I don't think that we can do anything to it, because if we try to engrave it, the copper will probably just gonna reflect the laser and not do anything. Let's give that a try. For this test, I have the copper plate there focused. I have a 10 by 10 millimeter square that I'm gonna try to engrave directly on the copper. But for this one, I'm gonna for sure use the glasses, because the copper surface is reflective and can hurt your eyes. So make sure that you use all the proper safety equipment. Okay, so let's see what happened. I don't have any high hopes. And just as I thought, there is nothing, not even a mark on the copper. To make the PCB work, I've cut a small piece out of the bigger part, and I'm gonna use black spray paint to paint it black, and hopefully we can then engrave it. Now I'm gonna leave this one to dry, but in the meantime, I'm gonna use just a black marker to try and do the same, because I remember that in school we actually used markers to draw on PCBs, and this is the way we created them. Let's see if that's gonna work with the laser as well. So I have the marker PCB inside. I'm gonna engrave my logo with 2000 millimeters per minute at 80% power. Let's try and frame it first. Okay, that looks about right. Let's see how it goes. And that kind of worked. You could see the logo quite clearly, but it's not enough to actually put it in acid and remove all the copper. For the one with the spray adhesive, I'm gonna actually do inverse of this. So we're gonna remove the copper on the outside and leave the plate with the copper. I now created this. This is a rectangle where I cut out the logo from it, and I'm gonna fill it with 1000 millimeters at 90%. If we preview that, we'll see that it's gonna engrave on the outside, and in theory it should leave a bit of copper where the plate is that we can then etch. Let's try and frame it first. Okay, looks about right. Let's start it and see how it goes. Okay, so that is now done, but it doesn't look like the entire paint was removed. I could definitely see some copper, but to make sure that we actually get it, I'm gonna run the laser, but in the different orientation one more time. Okay, so that didn't go as planned because my laptop battery died and I had to take out the charger. And if we zoom in here, you could see that it went to about here and then it stopped. Not that it's doing like too much difference, but you could see this here on the right is the area where it had 2 passes, and on the left is where it had 1 pass. I'll try to realign this and maybe start this from point in the future. We'll see how it goes. Okay, luckily Lightburn had backup, and I think that this is around where we were. Let's try and start from here. No, that's definitely not right. I think this is like reversed somehow. That's definitely not right. But hold on, we did not set the origin correctly. Okay, let's move it. Okay, framing looks okay. Let's run the preview till about here, and let's start from here. Nope, the alignment is not right, so I'm gonna stop it here and use the PCB as it is. So if you look, we were about a millimeter off there, and unfortunately we're gonna use this as it is. We'll see if here on the right we're gonna have better result compared to the left, because on the left we have one pass and on the right we have two passes. Before we actually etch this, I want to try and see if I can clean this up a bit, because it seems to be coming out, and I'm gonna use just a bit of IPA to wipe it. Yeah, you could see that's definitely much better result with the second pass. Yeah, that's definitely much better result where we have the second pass compared to just one pass. I tried to realign this to the best of my ability, so I'm gonna start it once again. Yeah, so that was a bit misaligned, definitely not perfect. And you saw me there, I manually pushed the laser on top of it to improve the alignment. But let's clean this up and see how it looks. Definitely not perfect, but there's nothing to blame on the laser. It's actually my fault that I forgot to plug in the laptop to the power. I think we still have a very usable result. And now let's prepare the solution to etch this PCB. For the etching, we're gonna use HCl and hydrogen peroxide as a mixture. Basically 1:1. This is 15 to 20% strength, and this one is only 3%. It's best to use something stronger. I haven't done this since high school, so I'm not sure how it's gonna go, but you must have a suitable eye protection when working with such chemicals. So let's try and mix some. So about a glass of the acid and about as much of the peroxide. I'm using plastic container, so it should be resistant to the chemicals. And also I'm using a piece of acrylic to stir it up and mix it. Okay, so we have our acid solution with hydrogen peroxide, we have our water, we have the PCB. I'm wearing a surgical glove because I'll need to reach out and take it out and put it in the water. So you don't want to do that with your bare hand. Here goes nothing. Let's see how this goes. Okay, so I could immediately see that it turned brown. Maybe it's a bit too strong. We'll see. We need to agitate this so there is fresh solution that etches the copper as we turn it on. I could see that it works because it's starting to get greenish color, and that is from the copper that is being released into the solution. Now I'll stir this for a while. Okay, so that looks as if has eaten the exposed copper. I'm gonna leave it just for a second or two more. Yep, I think that looks right. So I'm gonna reach inside and I'm gonna dump it in the water so we wash off the acid from it. Here is the result. You could see that there is actually no more copper left where we had exposed. So the acid and the hydrogen peroxide eat away through all of it. If I try to light it up from the back, you could see that light goes through. This line that we have here is probably remaining still, but let's try and remove the paint and see the actual resulting copper. Okay, to remove the paint, I'm gonna try some paint thinner, which seems to be working really nice. So here it is really zoomed in. I'm guessing that this line is where we tried the first time to realign it. Turned out that I didn't have the origin set correctly. This is our first try when I figured out that we are off by about a millimeter. Then the second try, and I think that by this point I turned it up manually, so I slide the laser manually, but we still have some artifacts that we've missed over here and something that we overburned. I'm guessing that this part here, what you see as a jagged edge, is where we missed it, and it's only once compared to double layers, and it wasn't actually enough to remove all the paint and expose the copper and the PCB. Now, as a process, this definitely works and gives us usable results. I'm really surprised by the performance of the Acmer. I was expecting it to be a toy, but it turned out that it's really something that I could definitely use on further projects. If you're interested to check it out, there will be links down in the video description that will take you to the page where you can actually grab a discount on the machine. Acmer was kind enough to provide some coupon codes. They'll be listed down in the video description, so be sure to check them out. If you would like to see me do other stuff with the laser, then be sure to let me know down in the comments. Make sure to subscribe, and I'll see you all in the next one. Cheers!